Dear friends, before we start this explanation, I would like to begin by stating that if you have any questions related to this topic, please do not hesitate to ask them in the comment section, and we will be more than happy to assist you with every possible answer. Hello friends, in this video we are going to learn about the LM393 IC pinouts, and then we will see how to connect a relay with LM393 step by step. So let us begin the explanation. The LM393 is a dual voltage comparator IC, which means inside it there are two independent comparators. It comes in an 8-pin package, just like this one you are seeing on the screen. Now, let us go through each pin carefully. Pin number 1 is output A. This gives the output from the first comparator. Pin number 2 is the inverting input, minus, of comparator A. Pin number 3 is the non-inverting input, plus, of comparator A. Pin number 4 is the ground pin, which must be connected to the negative or 0-volt line of the circuit. Now on the right side. Pin number 5 is the non-inverting input, plus, of comparator B. Pin number 6 is the inverting input, minus, of comparator B. Pin number 7 is output B. And finally, pin number 8 is the VCC pin, which connects to the positive supply, normally 5V, 9V, or 12V depending on your circuit. Now let us understand how the LM393 comparator works. When the voltage at the non-inverting input, the plus pin, is higher than the voltage at the inverting input, the output becomes high. But when the inverting input has higher voltage than the non-inverting input, then the output becomes low, or in other words, it becomes grounded. Remember, the LM393 has an open collector output. That means it cannot directly provide a positive voltage. It can only pull the output down to ground. So we always need a pull-up resistor at the output pin to get a valid high logic signal. Now let us move to the relay connection circuit. Here you can see the LM393 comparator symbol. We have the plus input and input connected for voltage comparison. The output pin of the LM393 goes to a 10K pull-up resistor, whose other end is connected to plus 12V. From the junction of that resistor and the output pin, a line goes to the base of transistor BC547. This transistor works as a relay driver. Because LM393 output current is too small to directly drive a relay coil, the emitter of BC547 is connected to ground, and the collector is connected to one side of the relay coil. The other side of the relay coil goes to plus 12V. A 1N4007 diode is placed across the relay coil in reverse polarity. This diode protects the transistor from the high voltage spike that appears when the relay switches OFF. Now let us understand what happens when the voltage at the non-inverting input, plus, becomes higher than the voltage at the inverting input. At that moment, the LM393 output becomes open internally. So the 10K resistor pulls the output high towards plus 12V. This high voltage goes to the base of BC547, turning it on. The transistor now conducts, completing the circuit for the relay coil. And the relay energizes. But if the voltage at the inverting input becomes higher than the non-inverting input, plus, then the LM393 output goes low, grounding the base of BC547. This turns the transistor off, and the relay de-energizes. So the relay on or off completely depends on which input pin has the higher voltage. So that was the complete explanation of the LM393 IC pinouts and relay driver connection. If you found this video helpful, do like, share, and subscribe for more such electronics tutorials. Thank you for watching.